Introduction to equations. This is really what most algebra is about, is finding the solution to equations. So here we go. In this book, it's lesson 2.1, Introduction to Equations. Here's a real-world connection to start off with. All right, suppose that during a storm, it rains 2 inches before noon and 1 inch per hour thereafter until 5 p.m. Table 2.1 below lists the total rainfall R, so R is rainfall, after various elapsed times. X, elapsed times, is how much time has passed since a certain time, where X equals 0 corresponds to noon. So here, X equals 0, that's the same as 12 noon. So each hour after that, so 1 o'clock is 1, 2 o'clock is 2, 3 o'clock is 3, and so on. And then the total rainfall, it's showing us the total rainfall is 2, 3, 4, 5, 6, and 7 inches. Okay, so there's a relationship between the time that passes and the amount of rainfall. So there's already, at noon there's already 2 inches. So and then at 1 o'clock there's 3 inches, 2 o'clock there's 4 inches. So the next thing is to write an equation modeling this information. You know, something that we could use to find times that aren't, say, in between 2 and 3 o'clock, like 2:30 or 3:30, something like that. If we have an equation that follows this same pattern, we can do that. So let's look at that. Between 0 and 1, 1 and 2, 2 and 3, there's just 1, right? 2 minus 1 is 1, 3 minus 2 is 2. And then also between the rainfalls, from 2, it goes 2 to 3, 3 to 4, 4 to 5, 5 to 6. So let's see if we can figure out a relationship. So our R, we can have R equals some relationship between X and R. So it's X is not equal to R, but X is what? Look at it, stop the thing, and see if you can figure it out. Okay, well I can see that each of the boxes of rain there is 2 more than what the elapsed time is, so X plus 2. So the data suggests that the total rainfall R in inches is 2 more than the elapsed time X, the time that's passed. A formula that models or describes the rainfall X hours past noon is given by R equals X plus 2. Well, that's just what we figured out. So now the next question is, well, 3 hours, what is it at 3 hours past noon, or 3 p.m.? We can look at our table and we'll see that 3 hours past noon, it's 5. So 5 inches. But we can also figure that out from our formula. So R equals, our X is 3 plus 2, I'll put a little thing around it just so you see it. 3 plus 2 is 5. R equals 5. So what about at 4:30, or 4.5 hours past noon? So it'd be 4.5. Well, that's not on our table. So here we can't even use the table. We have to use our formula. So let's do that. We'll have R equals, and in for X we'll put 4.5, which is how far it is past noon, plus 2. So our answer is R equals 6.5 inches. The tables help us see the relationship between the different variables. X and R are both variables. Depending on what time it is, you'll get different amounts of rain. So here at 4.5 hours, the table actually won't show, but the equation does show us what it is. What if we want to work from the R, the amount of rainfall? So when the rainfall is 6 inches, how much time? So now we're going to figure out what the X is. how much time has elapsed? Well, when r is 6 inches, we plug in the 6 for r, so we have 6 equals x plus 2. So what does x have to equal? Well, it has to equal 4. And notice we could have found it in our table. This one we could have found in our table. The 6 is up here. And the 6 shows us that the elapsed time is 4, which I've kind of scribbled over. But we can also do it from our formula. You can see that 6 equaling x plus 2, what do you have to add to 2 to get 6? And that's 4. As I said, a lot of times we're trying to find out what the x equals. What will make the equation true? You can see if we stuck different numbers in there, 4 works. 4 plus 2 is 6. But how about 5? Well, no, 5 doesn't work. 3 doesn't work. The only thing that works in that equation for 6 equals x plus 2 is 4. So 4 is the solution to our equation. Each value of the variable that makes the equation true is called a solution to the equation. Set of all solutions is called the solution set. Notice that braces are used to denote a set. So notice in this table below, the equation 3 minus x equals 1. Well, the solution set must be 2, because 3 minus 2 equals 1. It's a true equation. In 10 minus 4y equals 6, 1 is the only thing that works. 4 times 1 is 4. 10 minus 4 is 6. Okay, so the solution set for that is 1. Now notice in the last one there, x squared equals 4. There's 2 possible solutions, because negative 2 squared equals 4, and also 2 squared equals 4. So they're both part of the solution set. They both make true equations. Equations and expressions. So in the equation on the left here, 3x minus 5 equals x plus 1. Well, it's an equation because it's got an equal sign in it. Okay? Generally, if it's got an equal sign, it's an equation. If it doesn't, it's an expression. So the things that make up the equation, 3x minus 5 and x plus 1, those are algebraic expressions. When doing our combining like terms, we've been dealing with mostly algebraic expressions. Actually, only with algebraic expressions. We've had a lot of expressions, and just a number, 5, could be considered an algebraic expression. 5 equals 3x plus 1, for instance. Could be the 5 is an algebraic expression, and so is the 3x plus 1. I mean, they're both expressions. The expression could be a sum of terms. We learned about terms in the last chapter. We could have something complicated like 2x squared y plus 3y equals 5x minus 2. We could have that. This is 2 terms there, 2 terms there. They're both algebraic expressions. We're not going to have to worry about something like this, though, so don't get concerned.